Good afternoon, everybody. My name is Ronan McGlade, and I will be your facilitator today on behalf of Lean Construction Ireland. I would like to welcome you to Lean Construction Ireland's 29th webinar, the topic of which is Target Value Delivery of Construction Projects, and is hosted by Ballard from University of California, Berkeley. A little bit of housekeeping for you. If you have any questions this afternoon for Glenn, I'd please ask that you type these into the question box on the right-hand side of your screen, and we will consolidate these, and I'll ask Glenn at the second half of the webinar. If there are any questions that we don't get answered in time during the webinar, we will follow up with you via email afterwards. As I mentioned, the speaker for today is Glenn Ballard from University of California, Berkeley. Glenn entered the construction industry as a pipe fitter's assistant, transitioned to construction engineering, and in 1980 was named Manager of Productivity Improvement for a construction division of Brown and Root. He subsequently became an internal management consultant with Bechtel Petroleum, working on all aspects of project delivery and supporting projects in other Bechtel divisions, such as the South Texas nuclear plant. He began a management consulting business in 1987. In parallel, he began lecturing on productivity and quality improvement at University of California, Berkeley in 1989, and completed the transition from industry to academia in 2005 when he was named Research Director for the university's Project Production Systems Laboratory. He co-founded the International Group for Lean Construction in 1993, the Lean Construction Institute in 1997, the Project Production Systems Laboratory in 2005, and Lean in Public Sector in 2007. Glenn retired from his position as Research Director in 2019, but continues in a support role as a Research Associate for the Project Production Systems Laboratory. With lots of help from others, Glenn has developed the Last Planner System and Target Value Delivery, two key lean construction methods, both of which he continues to improve. A new current process benchmark for the Last Planner System is due to be published by the end of 2019, and Glenn is now leading research groups to develop better methods for the use of target value delivery, including conceptual estimating, which is estimating cost at completion prior to design, and using trade-off curves in aligning potentially conflicting stakeholder requirements. These will be incorporated in a future update. These will be incorporated in a future update of the current process benchmark for target value delivery. Glenn has a long list of publications, many of which are available at the website of International Group for Lean Construction, which is iglc.net. I'm now going to hand you over to Glenn to start his presentation. Thank you.
Hello, everyone. I'm going to start by giving you a definition of target value delivery. Let's see. Oops, it's not. Hang on a second. I seem not to be able to move the slides forward. Bear with me. There we go. Okay, but what I want to do first is I want to answer three questions today. What is TVD? I'm going to refer to target value delivery as TVD just to save on syllables. What are the benefits of TVD and how does it work? So this is the formal definition, if you will. It's a lean process for delivering value to public and private clients, owners, as well as other project stakeholders within their economic, social, and environmental conditions of satisfaction. That's a mouthful, of course, and but I do want to point out that although lean appeared on the world stage as a means for pursuing and achieving better economic outcomes, I think that it has proven itself to be the method developed by humans thus far, the best method for pursuing the triple bottom line of sustainability, economic, social, and environmental. But let me go to an example from our world of construction that might help clarify the definition. So this is from a study done for the National Health Service in the UK in 1998. And what they set out to do was to show in gross terms the different costs related to benefits in a healthcare project, in this case, a hospital. So if we set cost, the unit of cost as 1 for construction, in that terms of that same unit, maybe 0.1 would be spent on design, right? So together, the capital cost, the cost for the construction project would be a 1.1. In 20 years of operating and maintaining the hospital, there would be spent a cost of 4.3. Using the hospital to deliver healthcare, there would be a business cost of approximately 42. So you can see we're dealing here with order of magnitude increases. Now, the largest circle or oval on the right, labeled healthcare outcomes, should be bigger, to be accurate, bigger than the sum of all the cost figures, right? Otherwise, the project doesn't pencil economically, right? It's not a good investment. So what I'd invite you to think about is that the reason we have a project is to provide benefits to the project owner. And of course, in doing so, there need to be benefits for those who are delivering the project. Otherwise, they wouldn't do it, right? So, so I suggest that we have here a kind of, if you will, a graphic argument for the net benefits in use being the natural target for built environment projects. So what we're trying to do is to deliver the benefits in the big figure on the right within an acceptable cost, the sum of all these costs. So it looks at the whole life cycle of the product, right? Not just the construction project part of it, the capital project. So just to give you a little bit of insight into origins of target value delivery, TVD, I've traced it back to cost planning that emerged in the 1950s basically in every country that had its public institutions, schools and hospitals destroyed in World War II. And the problem that they faced was at the time they couldn't figure out how to provide public funding to support those projects without incentivizing increasing the cost rather than reducing it to what was reasonable and needed, right? So they came up with two basic ways to do cost planning. The first one is called elemental cost planning, or designing to cost. And this is a one in which you would set a target cost that's the most that you're willing and able to spend in order to get benefits, the desired benefits. And that ratio of cost to benefits, the cost-benefit ratio, is the fundamental target for the project. Now that same target is set for the second type of cost planning, but it has a difference. It's called comparative cost planning, or costing a design. And that comes into play when a client is willing and able to adjust target cost to acquire better value for money, greater net benefits in use, but that built upon the same basic target cost that's allowable. So already some key points. Most clients are multifaceted. They include the business owner. I need to change this. Pardon me, one second. So those who use the constructed asset for its intended purpose, and those who maintain and operate the physical facility. These are the primary clients. Additional include the neighbors, regulators, lenders, and then to take the healthcare example, the patients, the customers of the client. Meeting the different needs of these clients and customers is a challenge every project faces. Even a developer that produces buildings on spec, meaning that they haven't yet been sold beforehand, consider use costs, or they reasonably should, because that impacts sales or lease prices. So the second key point is don't design and then cost. The third one comes connected is that targets for net benefits in use can be either fixed or variable. If fixed, then the allowable cost is also fixed, the most you're willing and able to spend. If the target for net benefits is variable, the allowable cost is fixed relative to the net benefits target. So I will give you some examples that will hopefully help untangle that if it's tangled. So let's go right into benefits. I think often people get bored waiting for the punchline. So I'm going to deliver the punchline early and then go back and explain how those benefits are delivered. So this is an early target value TVD project. It was done in the United States, a medical office building for a healthcare firm in Northern California called Sutter Health. And they had started in 2000. They've just started. They committed to capital project lean project delivery for their capital program in 2004, I believe. And this was one of their early projects to test out the effectiveness of the lean approach and lean methods in their business. And so for this medical office building project, they did a benchmarking study against similar projects that they and others had built. And because they had the actual cost for those, they adjusted for differences between the reference projects and their own project, the one they're intending to build. And they came up with what we might call a market or a benchmark cost of $22 million. So it's not a huge project, but it's learning through doing, right? Then using a process that I will explain later, they set a target cost of $18.9 million. And the actual cost at completion was $17.9 million. And so we see that we have some good news already, right? So cost at completion was 5.2% below target and 18.6% below market. So that encouraged Sutter Health significantly, right? This was one of their very first projects. So in 2012, my research laboratory at Berkeley invited Sutter Health's chief planner and chief architect to come give us a report about what they had experienced with lean in the 7 years since 2005. And he reported, help you share. He reported that they were looking here only reporting lean product costs for lean projects over 10 million. And lean really didn't have the full valence, I don't think, in every case, but it always involved the last planner system and it always involved target value delivery, okay? They had done 22 such projects in that time, that 7 years. No projects went over budget or schedule. And remember, this is the cost planner architect saying it. So that's the planner saying that one. The architect says this one, with no sacrifice of scope or quality. In fact, what Dan Conwell said, his words were, our buildings are fit for purpose. And on the cost side, cost to completion was 3.4% under budget on average. But note that budgets were adjusted to previous accomplishments. So they had their own estimating and target setting benchmarks were adjusted based upon what they had proven they could accomplish, right? So it's even better perhaps than 3.4% says. And then final costs, that is the cost at completion relative to market, were about 15% under, okay? So this persuaded Sutter Health. These were all relatively small projects, no major acute care hospital projects yet, but this persuaded them to continue with lean project delivery, and apply it to their acute care hospitals. And here's the first one. This was Eden Medical Center Replacement Hospital. This is I think it's a photograph. It's a little hard to tell, but it was completed in completed in 2012, third quarter of 2012. So just after Dan Conwell's report, right? And here's how it performed. It finished ahead of schedule and under budget with no compromise to space program or sustainability goals. Remember the 3 legs of environmental objectives, sustainability, sorry, not environmental, sustainability. Construction rework was 15 to 80% less than trade baselines, depending upon the trade. Productivity 5 to 20% better than trade baselines. And then they were using BIM modeling, building information modeling, and they wanted to measure how well installation matched the model. And so they measured that against mechanical plumbing, and that they won the league. It said it was exactly to the model 99% of the time. And I must confess, I don't know what their unit of measure was. I doubt it was in micrometer measurements, but still, and I'll show you a picture of that in just a short second. Was electrical and framing were significantly less. There were also fewer requests for information. So these are, they often turn into change orders. On better projects, they tend to be confirming rather than asking, because the conversation precedes writing the RFI. Fewer RFIs, change orders, and failed inspections than on Sutter legacy projects, and tool time significantly higher than industry standards. And as I remember, I think it was in above 70%, and that's the sum of both direct and supportive labor time. Okay. So here's to compare the picture. It's a photograph on the left and a model image on the right. I'll give you a moment. It looks like they haven't completely hung everything from those from that rack, but it looks pretty good. Okay, some more key points. So TVD has been proven effective in reducing cost without reducing desired benefits. That's, of course, that's the gold ring, right? And secondly, benefits can be one or more of these: economic, social, or environmental. When TVD is applied on projects where the owner, designers, and contractors share risk and reward, that encourages collaboration and innovation. Yep. I can say more about that in response to questions. All right. Okay, so let's go to how TVD works. So here's this is a diagram showing how do you get from the very gleam in the eye, if you will, to the decision whether to fund this project, right? So let's just follow the diagram. If I had a pointer that you could see, I would use it. But at the very top middle, it says, what do I want? And so the client, perhaps with help from trusted advisors, would try to answer this question. They might do population growth studies. They may look at different types of market assessments, trying to estimate future demand. Or they may want simply to fill a gap in their portfolio and have a place in Sacramento that they didn't have before, right? So what do I want? What is it worth to me to have it, right? And then from that, you can answer the questions, what am I willing to pay? And that's, if you go back to that image from the National Health Service diagram, that means the sum of costs on the left relative in ratio to the value of benefits that are desired, right? And almost everyone has some, they are either limited by their expected acceptable return on investment or by their bank account. So you have to also answer the question, what am I able to pay? It's rare that a company is able to spend money on every project that anyone in the company can imagine. So that determines the allowable cost. So if you look at the column, the leftmost part of the and leftmost top, allowable cost, which I represent as AC, is what I'm willing and able to pay to get what I want. Right? Okay. But that's a very important foundation in TVD, but it doesn't fully answer the question, should I do this project? You also have to make sure that responsible, competent designers and builders will be willing to, what's that connection point, right, between what you want and what they need, right? And so that is, we get at that by doing a gap analysis between allowable cost and expected cost, what it would cost based on the market. Okay? And that's part of the research that Ronan mentioned earlier that I'm doing, is to develop or find more accurate ways of estimating the expected cost prior to design. So in the project definition process and programming. Okay? But once you have that expected cost figure, you can compare it to your allowable cost. And if you have more money than you need, right, then that's great, right? In fact, an owner in that situation might decide to add some benefits to the project because he has some additional room to do that, right? But if the more interesting and challenging case is when it's the opposite, right? That you don't have as much money as you need to meet the target cost, or the expected cost, right? So this is a bit of I have a good friend of mine who's really a very, very competent and professional estimator, and he suggests that during this process, you might think of it as the owner is playing a game of a bidding game, right? And so at various points in the process, the owner, again, perhaps with help, has to decide, can this gap be closed, right? Is it remotely feasible? And is the probability of reducing that gap, closing that gap, sufficient to warrant anteing for another round, right? Because every time you move forward here, you're paying money. You may not be paying money to designers and builders yet, though you might, depending upon the commercial terms, but you're spending money on internal resources. So if they say definitely not, right, it's not feasible to close this gap, then you either have to go back, revise what's wanted, reconsider what it's worth and your allowable cost, and do the gap analysis with expected cost again, right? Or you may give up and just kill the project. Because there are better projects in your stable, better horses that you want to bet on, right? But if it is feasible, then there has to be some means for validating what we might say is the business case, right? And there are various ways of structuring commercial terms that I'm not going to go into in any depth, but in some cases where there's shared risk and reward, the validation is done jointly by the owner and those companies, the design and construction companies that share that risk and reward. But in any case, there has to be some means of saying, right, is it feasible? And what I suggest is that you do that, it's best done by developing a project execution plan, a plan for executing the project as it's defined, right? With taking into account risks and opportunities, and then assessing, is there residual risk that is greater than that group, whoever the decision maker is at the time, is willing to bear, right? So that's the process of setting targets and deciding what to build. If you can't reconcile, square that circle, then the project again is either killed, but hopefully you can find some way of finding a way of matching up what's wanted and what's needed. Okay, but let's look at the accuracy of conceptual cost estimates, right? So traditional estimating, and there's some disagreement around this, but I think it's acceptable to say that traditional estimating is understood to be plus or minus 30% accurate in predicting cost at project completion before design. Okay. Now we also know, but there's a I will share one thing that we found in our research so far, and that's basically the solution is to don't try to estimate the cost by building it up from what you happen to know, but we can do an alternative is to model the project, then cost the model. Okay, so in other words, you're from the voice of the customer, you're understanding what they want, what functions are to be performed in the space, in the different functions in different spaces, or perhaps joint spaces in a building like a hospital, but need not be a hospital. And but you need to have a cost modeling software that is able to connect what is specified, right, by the customer with what's needed in order to deliver that functionality, right? So there are several in the world, and I will report simply on one of those here, and that's a company called Hattila, based in Helsinki, Finland. And I have from their most recent 32 projects, the average difference between conceptual estimate, that is the estimate of expected cost, right, done in programming, and the difference between that and cost at completions is a minus 1%. So it's on average, it's 1%. They come in 1% less, right? But there's some range. There's a standard deviation of 5%. So, but this is significantly already better, right? So it just is, as it says here, even one such example proves that greater accuracy is possible. But it's important to try to understand causality. And our research group's thinking is that it's not just a matter of having the right tool, but it's how it's used, right? And so we're thinking that we also need proactive steering to targets for what customers value and the constraints on delivery of that value, which are principally program, cost, location, and time. Okay, so just to say a few words about, excuse me, about how Hattila's cost modeling software is called Taku, and I think that means cost model, but I don't speak Finnish, so I may be wrong. Excuse me. So it's what's called a constructive model, structured using engineering logic and formulas embedded in the software. And for example, if you want to calculate the number of lights needed to provide a target illumination in a space, here's the function, the equation that's used to do that, right? And so these are embedded in the software, and so once you say, I want this illumination in these spaces in this building, then it adds up what you need. It uses this equation in order to calculate the number of lamps you're going to have, right? And that's just one example. I think there's, I don't remember, 500,000 lines of code in the software. So it's their fifth computer version of the tool. So the conclusion is that it's not necessary to first produce a design solution to count the number of luminaries, the lights, or the size of the main switchboard, or fill in the blank, as the designers use the same formula to determine the number of lights. So the next issue is how to steer to targets. So we talked a bit about how to set them, but setting them is only half of the, or maybe not even half the game. You've actually got to figure out how to hit them, right? And so to use the term steering, and I suggest this term because it suggests or brings to mind the image of driving to a destination, right? You don't just say, okay, here I want to go from A to B, and I want to be at B by time T, right? Now, you might be able to do that with self-driving cars, but in projects, we haven't been able to figure out a way to make them self-driving. So they need to be deliberately steered towards their destination. You turn the wheel in order to make the curve, turn into a different intersecting road, and so forth, right? So that happens in a sense in project definition, in the programming stage, where you're helping the client by providing the feedback, the gap analysis between allowable and expected. You're helping the client make the best decision for them, right? And then in doing the validation process, make sure that it's also an acceptable solution for the designers and builders who will actually construct the project, okay? But steering continues into design. So within design, one thing that we need to note is that, well, I'll say that in just a second, sorry. So we first steer the client, then design, then construction, right? So for determining how much and if to fund a project, right, all you'd really need is the global target cost and the global target benefits, right? And obviously, if you have both, you have that ratio of benefits to cost. But you can't steer design with just that level of detail. Because design is produced by system and component, the cost model must be able to be revealed at that level of detail, right? And so to go back to Hatala's Taku, and it's not the only one again, but I'm using that as an example, it automatically, well, at command, it reveals the level of detail that's desired. And that level of detail can be by system and component for steering design, and it can be by work package for steering construction, okay? So it informs not only design, but also procurement and then construction. So construction is produced in work packages, so the cost model needs to be able to be expressed that way as well. Now, formally speaking, though this goes beyond perhaps your concern, or perhaps not, the steering continues in building use, right? Or constructed asset use, to generalize it. So that would include all of the cost centers and the business use cost centers, right? For maintenance, facility operations, business use of constructed assets. So in all cases, steering is done through feedback provided by cost models. So we've talked a bit about 1, 2, 3, 4, right? So where we allocate the target cost to systems, subsystems, and components, have cost modelers provide cost guidelines to designers upfront before design begins, incorporate value engineering, value management tools and techniques into the design process, And here I want to caution, I don't mean doing value engineering as it's come to be used, and that's as an after the fact evaluation of a design. I'm talking about using value engineering methods to produce the design. Okay? And then use computer models to automate costing to the extent feasible. So that we might call it the technical side of TVD. But there's also a social side. And I again appeal to Sutter Health for what they call their 5 big ideas for emergent outcomes. So I'm just going to go through them quickly, but the first one, collaborate, really collaborate. The idea there is that we shouldn't confuse collaboration with being polite. Obviously, we want courtesy is important, but you are on the project because you have something to contribute. And if you are quiet, if your voice is not heard, you're not doing your job. So I have a personal kind of a test on a project. If it gets too quiet, especially in the design process, but not only, then there's something amiss, right? So collaborate, really collaborate is not just don't bite, right? It is disagree politely and collaboratively. Find solutions jointly for joint outcomes. Then optimize the whole, not the part. And so that is easier to do when the commercial terms are supportive. So if you're being paid for the benefits to cost, the net benefits in use, then obviously your interests are aligned with that of the client. If not, then we have to be careful about potential conflicts. Tightly couple learning with action. We don't pretend. One of the hallmarks of Lean is that it's all about learning, right? All about learning and all about people development. And so if we can use every action on a project as an occasion for learning, right? And for subsequently better action. But that means we have to have a learning mentality, we have to reserve capacity for reflection, and we have to treat a breakdown not simply as a problem to be overcome, but as an opportunity for learning something we didn't yet know. Projects as networks of commitment. This is a way of seeing a project not just as a production system, but as a social system, right, that matches with that production system. And so if you think for a minute about the unit of analysis in Lean is the immediate customer-supplier relationship. And that occurs most immediately when I am in a process and you are my customer, right? And the person next to you is your customer. So everyone's a supplier and a customer. And if those handoffs, if you will, are not properly formed, if the people don't share, the customer and supplier don't share the same understanding of what's needed and what's wanted, right? Then how can we expect the processes in which they participate to function as well as they can? And if that's true, how can we expect our projects to function as well as they can? So building and projects as networks of commitment is absolutely vital. And the reliable promising process is the key method for doing it. And lastly, increased relatedness. The idea here is to get to know people as individuals, not as position holders, right? A good friend of mine, Will Lichtig, has said some years ago, you know, unfortunately, the norm is that we enter projects as strangers and we leave as enemies. Now, that's not acceptable. We're not going to entice people to come into our industry as long as that's the norm, right? Okay, so let's see. This is a complicated graphic, obviously, and let me just see if I can point out a couple of things. One is that it's another Sutter Medical. This is the Sutter Medical Center, Castro Valley, which is actually the same project we saw before, but this is a report is produced every month on that project that during the course of design and construction, okay? And what it shows is the amount of cost reduction needed in order to reach the profit goal. And that means the profit target, the share, because they're sharing risk and reward, right? And so the architect doesn't have a separate contract, but is paid based on a previous agreement, or an agreement that's negotiated, based upon how well the project does in meeting its targets, right? And the gap analysis continues in design here, where we're trying to steer design in order to reduce the cost of construction and use, but without reducing benefits delivered or value delivered. There's other interesting things on here, but look at the lower right-hand corner, risk and opportunity tracker. And so what they tried to do was to keep track, and I don't think this is peculiar to them, but to keep track of risks and opportunities. That is the possibility of spending more money, having more, let's say, more money drawn from contingency, or the opportunity to add money to contingency and thus provide super profits for the risk pool member companies. And if you can track that and make some more or less arbitrary but reasonable assumptions, almost reasonable, you need to have about twice as much in opportunities as in risks in order to come out where you want to be. Okay, so just very quickly, 3 drivers of superior performance of TVD projects. The lean construction philosophy and methods is absolutely critical. It's not going to work without it. Then the second one is organizational integration, bringing downstream players into upstream processes and vice versa. If we don't have the designers engaged in the construction process, how can they learn better about their design? And then lastly, shared risk and reward. And I'm not saying that TVD only works with integrated project delivery or project alliancing or other collaborative forms of project delivery, but it does help, right? But there are other ways of dealing with aligning commercial interests. As an example, my own university system, it's a 10 campus system, and it has its own procurement restrictions in state law. And one of those restrictions is that it can't sign a joint, a multi-party agreement, right? Which has been a characteristic of shared risk and reward approaches. But what they've done instead is to use incentives, positive incentives, in order to so rather than use many words, let's say you're setting targets for hitting schedule milestones, and everyone on the project benefits from hitting those milestones, right? So there's a certain amount of money attached to each milestone. So all 3 of those need to be paid attention to. That is, are you really operating with the lean construction philosophy and methods? Can you beneficially integrate organizationally? And how are you going to structure commercial terms to align interest, however that is done? So lots of more key points. So decisions about moving projects forward are made with incomplete information, uncertain information. Different methods of conceptual estimating have different levels of uncertainty. Setting achievable targets is necessary but not sufficient. Proactive steering to targets throughout design and construction is also required. Only the primary client can change targets. And there are a number of ways to structure commercial terms and to allocate risk and rewards that enable steering to targets. So I'm showing this slide. I'm not going to go into this in detail, but just to alert you that when you get the slide deck, it will include slides talking about these 4 key tools. And if you use the notes page view, you'll be able to see the words that go with the slides. But I want to leave times for some questions, so here we go. Okay, back to Ronan.
Glenn, thank you very much. Thanks for that. It was a very insightful presentation. Yeah, we've a few questions that have come in here that I'm going to read out to you now. One of the first question here is, all projects set targets and try to achieve them. How is target value delivery different, Glenn?
Okay.
So all projects set targets and
Right.
try to achieve them. How is TBD different?
Well, I think it's different in two main ways. One is the way targets are set, and the other way is the way that we steer to targets, right? So targets are set with a deliberate attempt to first make sure that what the client wants is something that they are willing and able to pay for, right? And so that's one part of it. And then the second one is that in steering, we're not just asking people to read their contracts, but we're asking them to work together to solve a joint problem, right? And even when contracts are stipulate individual and different separate financial outcomes, the very fact that collaboration is hugely important for my profits and your profits, right, should be persuasive for people to collaborate. Now, you have to pick your people well, pick your companies well, and the people within those companies, right? But you also have to be using that approach, right, which is part of the lean philosophy. So I hope that was helpful.
Okay. And actually, you mentioned steer and steering again, and you did during your presentation, leads me into another question. One of our participants asks, steering is an unusual word for managing a project to achieve its targets. Why not just say managing?
Well, I think I actually did talk about this in the presentation. I think it's helpful to think in terms of key images. And the image for me is that we want to think about managing the project, not just as a matter of reading reports and ticking off things, right? And then beating people up, read your contract, that kind of stuff, but rather collectively figuring out, well, what do we need to do now in order to get where we want to get, right? And that's not like how managing is normally conceived, right? But more like steering a car to its destination.
Very good. Can you explain more how set-based concurrent engineering works with TBD, Glenn?
Well, that's one of the slides I didn't show. So set-based concurrent engineering came out of lean product development, and it's typified by Toyota, but not restricted to Toyota. But in that process, they operate on the principle that everyone who touches or is touched by a product should be involved in its design, right? And so that's the idea of concurrency. So that it's really the organizational integration aspect that I mentioned as the second point of the key drivers, right? So that's concurrent engineering. But in lean product development, the history tells us that they first tried doing it just with organizational integration, but without really managing the design in a way that promoted collaboration, right? And the set-based piece of it is that other piece. So set-based engineering means you don't rush to a solution to your design problem, whether a small part of it or a big part or the whole thing, but rather you use all the time and money you have. So we're not trying to economize on design, we're trying to optimize the whole. That's a good illustration of optimize the whole, not the part.
Okay. I've one participant. one participant here is
Go
asking
ahead.
two questions. Glenn, do you find any resistance from architects, number one? And does TBD reduce design creativity? So I suppose the first one there, do you find any resistance from architects?
Okay. Well, I can tell you what happened, but I can tell you my own experience, but I think Hattela's experience may be relevant. They started doing this type of an approach in 1980, so they had considerable experience. And they report that initially architects were resistant because they thought that they were being told how to design, right? But over time, they've made an entirely 180-degree turn. And now the architects have learned to value the feedback so that they do less rework, they produce better satisfied customers, right? And so there may be some education required. And I think that if you do run into that problem, I would encourage you to reach out to have the architects reach out to fellow architects that have experience with TVD and get their input, their testimony. They're more likely to be persuaded by peers than by you.
Okay.
And then on creativity, no, I think I actually have I think it's an interesting idea, but then I would. But I think that in set-based design, one of the key issues is making sure that before you start designing, that your different design criteria are compatible, right? That if they're not compatible, then that's a cause of rework, right? And so there's some evidence for that, quite a bit of evidence actually. But I think something else is going on there is when you have a conflict between design criteria, you can either relax one or the other, or you can invent your way out of it. And I think that creativity is promoted not just by saying, well, let's be creative, but by pointing people to a specific problem and saying, this right now, the design space is a null set, right? We don't know how to take something from Toyota, from automotive engineering. We don't know how to have a super quiet car, right, that has high fuel efficiency. Okay.
Okay.
Right. Because if this is actually from a case in the development of the Lexus program, Toyota was trying to break into the luxury car market, right? You know, that market that's populated by BMW, Audi, and so on, right? And they had done performance benchmarking against that group of competitors. And the chief engineer Suzuki said, look, we can't just be as good as they are in any of these on all these performance dimensions. We have to be better. And that meant that they had to have a car that was super quiet, yet lightweight, right? And so forth. Now, let me unfold that one just a little bit. So at the time, the accepted engineering solution for vibration-induced noise in a car was mass. But if you set your weight target low enough, you won't have enough mass to absorb the vibration sufficiently to meet your noise target. I hope that makes sense, right? So that's an example of conflicting design criteria. And what Suzuki, the chief engineer, did was he took a kind of a roundabout way to the solution. He went to the powertrain engineers and persuaded them to redesign the engine, just a shop block model initially, to much tighter tolerances. It reduced vibration and it increased fuel efficiency. Okay, so I think that in set-based design, TBD generally promotes creativity when properly managed. But I think we really have to take set-based design seriously and start with identifying and resolving, deciding what conflicts between design criteria exist in our project.
Very good. Okay. And one last question, Glenn. I think this is a big one. Can you explain more how Last Planner system works with TVD? Can you explain?
It works. I'm not sure what audience's experience with Last Planner is, but it's basically a collaborative approach to planning and executing work. Right? And it applies in every type of work as far as we can tell. You may use slightly different sub-methods, right? Some so-called agile tools are perfectly well fitted, perhaps sometimes with slight adaptation, to the management of design. But because they were developed in software engineering as opposed to building design, we have this idea that they're not lean. But I think that's just a category error. A method is lean if it is fit for purpose in pursuit of the lean ideal to deliver target net benefits and use, right? In accordance with lean principles, right? Respect for people, continuous improvement, and so on. Did I get that one? I might have missed it a little bit.
No, I think you hit it on the head. I think you hit the nail on the head.
Okay.
Glenn, great. I'd like to thank Glenn on behalf of all the participants, Lean Construction Ireland, and myself, for his time this afternoon or morning where you are, Glenn. A copy of this webinar will be sent out to everybody who attended the webinar, and also will be available on the Lean Construction Ireland website, which is leanconstructionireland.ie. Our next webinar will take place on the 22nd of January, the title of which is Magic Mirror on the Wall, Who's the Fairest One of All, which is putting the spotlight on quality and is presented by Peter Love from Curtin University. We'll be sending out further information on this via LinkedIn, Twitter, and newsletter in the coming days. Glenn, thank you again on behalf of myself and Lean Construction Ireland. You can follow Lean Construction Ireland on LinkedIn, Twitter, Facebook, and through the website, leanconstructionireland.ie. Just like to wish everybody a good day. Enjoy the rest of your day and be lean. Thank you very much, everybody.
Okay.